All right. Once you're in, please let me know if that you made it, huh? Yeah. It's showing this. Okay, good. All right. So at least it's showing something. Okay. So what I was trying to say also from the last lecture, now that we can begin. So inheritance and abstraction is definitely your best friend, especially when it comes to the ability to make your design a lot more flexible and a lot more reusable. Okay. And a lot of the times it's the abstraction and the slash inheritance that you're actually doing is really the true concept that you're trying to convey rather than the details. Okay. So for example, I have I have a glass door connected to a wooden house. Okay. And I have a metal door connected to a brick house. Okay. And then I come back later and say, well, I can actually put down the metal door on the wooden house, and I can also put down the glass door on the brick house. When I'm making things a lot more complicated, the concept that I'm trying to convey is made it a lot more complicated than it really should be. What I'm actually trying to say is that any house, exactly, any house should have a door. Okay. And whether that door is wooden, sorry, we said glass or metal, it should work with any house, whether it is, what's it called? What did we say? Wooden or brick. Okay. And this way, if I do happen to add another type of door, it's already applicable to any type of house. And if I add a new type of house, it's already applicable to any type of door, and just have a one-to-one relationship between a house and a door, that a house should have a door and a door should have a house, and that's it. Okay. Now, if I go back just for a moment, okay, and I look at my inflexible design, where I had here X door, Y door, and then I had here X house. So in my code for X house, because I can put in any type of door, I have to put code in here about X door and X house. Oh, sorry, not X door. X door and Y door. In come a new type of door, Z door. I have to go back again and I change the code over here, compile this entire class. Although I've actually added code, I didn't really touch anything from the previous code, and all of this unnecessarily. Okay. Like, to make matters worse, if there is a bi-directional relationship, I would have to come here and I write something about X house, write something here about X house, and X house over here. Okay. But let's even make the matter a lot more complicated. I have now Y house over here, and I have Z house. Yeah, you can see the whole thing is now starting to explode. Oh, somebody has a mic on? Okay, that's okay. That's all right. Yeah, I'm hearing my echoes. Okay. But as you can see from your screen, now, how many links do we have? How many strings do we have? So many, right? It just really so many. You can just from the top of the iPad, just reduce the zoom because you don't really need to listen to me on the, well, I think you're the best IT support now that we have. All right. So as you can see, the complication and the relationship is getting, and the number of relationship is increasing exponentially every time I add a new type of door and every time I add a new type of house. All right. When really what I was trying to say all along, that a house should have a door and a door should have a house. Okay. And now with my old design, I'm going to go back again. With my old design, okay, I would have an object of type door and an object of type house. Okay. And what it's going to refer to door to house is a variable of type house. Okay. And that's not going to change. The concept of a house is very stable. That's not going to change anytime soon. Okay. So if I add a new type of house, I don't really have to do anything to the class door or any of the subclasses of door. Similarly, if I did add a new type of door, then I don't have to do anything with the class house because class house has a variable called door. Okay. And remember polymorphism, the outside is something, the inside is something else. So the outside says door and it remains door always. The inside might actually change, maybe from X door to Y door to Z door. And really what happens, especially if the parent class is abstract, in other words, there's no actually object called door per se, what it does, it starts to execute, say, a function of class door, realize, oh, door is not even a class there to begin with. So what happens is then it looks inside. And when it looks inside and says, oh, Allah, there's something inside called X door, and X door has that function implemented, then I go execute that. Even if the parent class is not abstract, it still gets overridden by polymorphism because it says, I'm going to execute the more specific function coming from the more specific class rather than executing the more abstract function from the more abstract class. All right. And with that, because doors always has a variable called house and house has a variable called door, it doesn't matter how many subclasses I add or remove. All right. I'm trying to get the this thing to show up over here. Yeah. What am I doing wrong? You reset, huh? Okay. Well, as he's fixing it. So now when you open up your Moodles, there's a little exercise that I have for you there. And under handouts, for those of you at home, under handouts, you'll find out there's something, a file called Design Flexibility and Reusability Exit. Do you find it? Okay, click on it. It's a PDF file. It has an exam question. That's actually an exam question that I brought before in the midterm. Okay, and it showed up in quizzes before. And it's showing you, oh, sorry, talking to, and it's showing you an example of a bad design that we want to fix. And this particular example is about tires and cars, and we're trying to connect every type of tire with every type of car, but we're doing it the manual approach and the direct approach, which makes things very complicated and very inflexible because every time we add a new tire and every time we add a new car, we start to change a lot of code. So a lot of effort for very little change. Okay, that makes it inflexible. And to make it matter worse, if I do like a class and I want to grab it, you see there's a lot of rectangling links between the different classes. So that means I'm dragging a lot of classes with me. I don't want to drag all these classes with me. Okay, I like Xdoor. I don't like the rest of the design that you have. All right. So what we want to do is we want to be able to make our design more flexible by saying that every type of class, sorry, every type of vehicle should have, oh, there we go, 6 in 1. I'm getting closer. Every type of vehicle should have any type of tire. And not only that, we're making our design flexible for the future because we might consider new types of vehicles like motorcycles and so on, and new types of tires as well. Okay, and then we have a maintenance person, and that maintenance person could be doing the maintenance on any type of car. So again, we did have a direct relationship between the maintenance guy and the different types of vehicles. And again, this is that direct approach with the concrete classes is very unstable. Okay, what we want to do is we want to refer to the general concept that saying that a maintenance person can perform this maintenance on a general on any general type of vehicle. All right, so have at it. Those of you who don't have a piece of paper, I have some paper with me. No, no. What? But what was wrong? Just I don't have to call you every single time.
The input, it has to be 2, not 1.
At 2.
Yes.
And I made it at 1. Huh?
Yes.
That's it. خلاص. Okay. Thank you. All right. Now, those of you at home, are you able to find the exercise that I'm talking about? Let me see if there's a chat. Yes, yes, yes. Okay, good, good. All right, so I go like this. And where was it? It was over here. I know it's gonna log me. No, it's good. Okay. Click on that. All right. So look at this, huh? And that's just ugly, right? That's a very ugly design. Let me just increase that. So every type of tire is connected to every type of vehicle, and the technician is connected to every type. We don't want that. We want the general concept of any tire on any vehicle, and that technician should be able to handle any type of vehicle. Okay, just giving me give it a crack and let me see what you come up with. Okay, so the first two are pretty easy, huh? When it says having more types of tires and more types of vehicles, yeah, we're just gonna do. The third one needs a little bit of thinking. Okay, now the third one so far is just a function. And again, I don't want to be connected to directly to the concrete function. I want to generalize the concept of maintenance. Okay, so it's a little tricky. It needs maybe a little bit of thinking. See, the design here is so bad that even the concept of a maintenance wasn't even considered as a class on its own. All right. So we're gonna go like even one step backwards to even recognize that maintenance itself is a class. All right. So narrow vision, this design, thinking that there's gonna be oil maintenance and that's it for the rest of our life, just a single maintenance. Yes. This صراحة, to be honest, is a Canadian type of tires. Now, in Canada, because the roads get slippery in the winter, then they have tires that are very sticky to the ground. Okay, in the summer, they become too much of a heavy load when the roads are dry. It becomes a heavy load on the car because it's sticking too much, and then you're using more energy, which means you're using more gas and more petrol and so on. So then, what you really want to do is you want to switch to regular, what we call all-season tires. And then again, back again, all season, once the winter rolls in, it doesn't perform very good on ice. Okay. Nonetheless, from your point of view, it's X tires, Y tires, Z tires, it doesn't really matter. Same thing with the vehicle types. We don't really care that much anyway. Hmm? Yeah, that's the obvious answer. Yeah, so we've solved 1 out of 3 problems. Okay, and inheritance, you just use abstraction / inheritance. That's your best friend. You gotta reuse that over and over and over again. Girls upstairs, how is it coming along? Okay, so how far did you reach along? Can you, or send me like what you've drawn on private? You can send it on private in the chat. On Zoom, private chat. You don't know how to, okay, it's okay. You can just tell me like, so you created like say an abstract class called vehicle. Okay. And tires and maintenance. Very good. That's it. That's really it. All you have to do is just connect them all together. All right. Honestly, there's a bit of something called a type of association which you haven't covered yet in the course, but that's fine. I wouldn't have docked you down on it anyways at this time of the year. Well, actually, no, because maintenance is performed just on the vehicles, not on the tires. So it shouldn't actually be tricky. It should be straightforward here.
So we can have a class maintenance the type of maintenance.
Not inside it. I don't like the word inside it. Underneath it. Okay? Always think classes, not functions. Classes. All right?
Think about this example as a class. So we have to list all the type of tires.
Yeah, what we currently have. When the future comes for new types of tires, we'll add them. Okay. Now, those are you at home. How far along are you coming? Can I hear some feedback? For those at home, if you want to share with me in private chat your work so far, I'll be more than happy to give you some feedback on it. Like make a screen capture and then send it to me. All right. So let me see. No, you're good. Now you got to show the different type of maintenance. And where did the technician go? Or you killed the guy, huh? That's not good. So you're on track. Okay. I mean, how far along are you going? Can okay. You didn't connect them together. Okay. The tricky part is connecting them together.
We made glass for maintenance.
Yeah. Mm-hmm.
We can make it all into the vehicle.
Yeah, because you're performing maintenance on the vehicles, not on the tires themselves. If you want to do this work, I don't know if you have a pen with you. No, you're not. Okay. So, again, for the future, guys, maybe working on a phone is not very feasible. So you want to get an iPad or laptop or just a regular notebook paper with something to write with, because we're going to be coming across this situation quite often. So at least on the days where you have Dr. Attar. Okay, so we'll stop here because we got to move on then. All right. Now, I want to hear from you at home. What should I do? Can you tell me how should I create that design? Go ahead, speak. Otherwise, I'll have to call you out.
We can have a general class tires.
A general class tires.
Yes, and then
Okay, remember, just let me stop here. So she said general class tires with an S, but it's always tire, okay? Because at any point when we create an object of type tire, we only have the one tire, okay? So it's a very common mistake. We say students or professors. That's actually student and professor, okay? Anyway, so, and inside, I'm assuming, who's speaking?
Yasmin.
Yasmin, okay.
We have all season and performance.
Mm. I need to make it, it doesn't snap into, yeah, it's very annoying feature. Is it all season? And then performance. Okay, and then future types, you can just show them like that with dotted. Okay, now, guys, girls upstairs, what should we do next? Well, yeah, winter's gonna come in the future. So winter comes in here, that dotted part. Okay, so we've taken care of that. Class called maintenance, good. All right, and underneath it, not necessarily, no. Underneath, when I say the word underneath, I mean the types of maintenance. So we know we've got oil, okay? And then we have, all right, exactly, a new type of maintenance, right? And then easier than maintenance, so you got the hard one. So boys at the bottom, on Ranim, of course. Anyone can say boys and vehicle. Okay. Which has two classes or more, but right now we're just gonna have car. We're gonna have truck, and then we go the dotted thing for more. Okay. Now, before we get to the technician, so we said tire. Okay, let me just go use the blue here. So tire with a vehicle, and vehicle with the maintenance, and then the maintenance, who does it? Exactly. Technician. Okay, and that's it. That's basically it. That will be your answer to. well, so far we're just doing bidirectional for now. We haven't gotten to that part of the course. Now, the more important part here, huh? So we did the abstraction here, abstraction there, abstraction here. And if you think about it, what we're really saying that maintenance happens to any type of vehicle and tires happen, and then it's the technician that does all these sorts of maintenances. Okay, from a general point of view. Okay, matter of fact, this is what we tend to think of when we actually pull out in the gas station, that the person who's standing there, he's able to do all of those before you're thinking that, oh, this person can put together, you know, the Chinese type of tires on this type of vehicle or anything like that. We're thinking in general that this is a technician who can perform general maintenance and so on. And in general, you always think cars and tires and car and so on. Okay. A little maybe later on, we might consider cardinalities. Okay. Yeah, I must say that a vehicle will have 4 tires. Okay. Then I would say something like 1, oops, a 1 and a 4. Okay, so that's 4 objects of type tire. And this is why we don't like to say the class name called tires. Okay, because otherwise I would have 4 objects of type tires, which is not the case. We just have 4 tire. Okay, and let the plural just be in our heads. Okay, so that's it for that exercise. Yes. Yeah, they're called association. I have them in blue just to stand out from the rest of the. Let me just do a little bit of a like that. All right, so you can actually see better the actual relationships. It's very odd that I'm actually seeing it over here. What am I? It's like somebody's drawing the same exact thing I'm drawing. It's like, and that's actually me. Okay, guys at home, girls at home, any questions? So chat, I see there's 3 messages in the set. Yes, create a class called tires. Okay, added a vehicle class. Okay, thank you, Noof. But did you follow the answer to the exercise? Do you understand the answer to the exercise? Can you write down in the chat if you got it, or if you have any questions? You can also ask on the chat if you have any questions. Oh, I'm getting more versatile with this whole online thing. Is just okay. All right, so we'll move on now to chapter 2. And I think somebody has their speaker up, because I'm hearing my echo again. If you don't mind, I'm putting headphones. Okay, that's good. So it's all fixed now. Okay, so chapter 2. I said Ahmed Yabla. Oh yeah, because you. I was like, why did that happen? Okay, so now we're going to begin chapter 2, and we're going to talk about software architecture. Okay, now software architecture. Why did I actually remove this? That's very silly of me. So software architecture. Let me close this up. It's where we begin the most initial step in the solution phase. Okay, so we begin. Remember the development life cycle. We begin with requirements, followed by design, followed by implementation before testing, yeah, and then testing, and then all of this is what we call in-house. And then finally we have maintenance, which is we don't call it, we call it production. We don't call it out-house. Okay, but in here we draw a line, and we call this the problem domain, and over here we call this the solution domain. Okay, when I consider the design phase, which is the first thing that we enter, there's actually 2 levels of it. Clear this. Okay, so once I hit the solution phase, right, design is a big box as such. Why is it doing this? And then I have high level design, then I have low level design, and usually, depending on the terminology you use, it's the high level where I start to do my architecture, okay? Now, an architecture is in itself not the solution, but rather the infrastructure for the solution, okay? You still have a lot of work to do in the low level design and thinking about the small details. Now, when we begin, just like we begin with any urban design, okay? Even for, say, the city of Riyadh over here, okay? I remember just, what was it, 6 years ago, that if you go north of Northern Ring and King Fahd Street, you know, these areas, Hattin and Malga and all of that was just a desert, okay? But still, on the map, so here's the Northern Ring, here's King Fahd Road, and this desert, although it didn't have anything in it, it would have kind of like the main roads, right? Although there's nothing there, okay? Now, the point is, you think of a city or you think of a large area, you think big first, and then you start to go down to the lower level. It just makes perfect sense. It absolutely makes no sense to start off by thinking, this is where my house is gonna be, all right? And then build the whole city around it, okay? It just doesn't work out this way, all right? When we start to think of an architecture, think of, here I am, I got a wide area. Let's just talk about a university. We're gonna build a university, okay? And this is the land area that we're gonna get to build a university. What's the main decisions that you're gonna be making at this point when you start to build the architecture for an entire campus? Okay. Landscape, yeah, okay. And within the landscape, we start to think of, no, before the cost and all that, I mean, just the look of it. The design, yeah. And yeah, just give me some more, huh? That's too detailed at this point. That's far detailed. You might actually think of some, I'm actually gonna give you an example from KFUPM. That's literally the way it is at KFUPM, okay? A university that I used to work for, KFUPM, okay? You come in, you have an area in the middle, and that's for academic buildings, okay? And then you have, here is faculty housing, where we live. And then over here is student housing. And then at the front, this is the security gate, all right? You obviously think of those first, before you even think this is the chemistry building and this is the engineering building. You think of these later, okay? So once we thought of that, then I can think of the chemistry building, I can think of the engineering building. And then after I think of the engineering building, I start to think, well, this is what the first floor is gonna look like, this is what the second floor is gonna look like, okay? Kind of like the building that we're in right now, right? Do you think they thought of this room before they thought of the floor first? Definitely not, they think of the floor. And then after that, they think of S1001, which we're in right now, and how is it gonna look like? And then they start to think about the paints and the carpet and all that stuff, all right? Before we get to the whole room thing, all right, there are major ramifications to the decisions that I have, okay? Now, what if I took the security gate and I put it over here? Okay, what if I put it in the middle of the campus? That doesn't make much sense because you're already inside the campus, all right? So yeah, so without even bothering to create the detailed design of the security gate, I know I've already messed up, okay? So it's kind of like being a football manager, all right? You're not necessarily going to coach your team to win. You can't guarantee it, but at least you can put down a green flag to guarantee that they're gonna fail, okay, if that's the case. What you're trying to do is at least make sure you put the groundwork for them to succeed, okay? Here's another decision that we might have not thought about, but they've thought about at KFUPM, okay? What if I take the academic buildings from here And say take the faculty. Okay, take the faculty out. Put the faculty in the middle. Okay. Put the students over here, and then put the academic buildings over there. Obviously, you can't read what I'm writing, but you get my point. What that means is that students, every time, yeah, they're gonna take more time going back and forth, which is something that they're doing quite often. Yeah, the faculty from their perspective is exactly the same like it was before, but for the students, it's a lot more annoying now. Not to mention they might even need to go through faculty housing, which is invasion of privacy and all these sort of problems that can exist later on, okay? Here's another problem, okay? I've given the faculty housing a lot of space on my campus, okay? Too much power, too much control. You know, this is making it the jewel, the showcase of the campus. Where really, when you want to walk in, you want to see the main academic buildings and the structures that identify. You know, especially if you know they have the water tower. It's very famous as a logo for the actual university. Okay, so what I'm trying to say here is, at the beginning of the architecture phase, you have this white space. We have all the flexibility in the world, but also with it, all the responsibility in the world comes along with it as well, okay? If we set up the infrastructure wrong, there's gonna be major ramifications back. It's not a big deal had I made this room that we're in maybe 1 yard extra or 1 meter too small, right? However, if I place the building in the wrong area, if I even chosen that the academic buildings would be in the wrong area of my campus, of my land, that would have much more major ramifications later on, okay? Back again to the campus example. Here we are. So first of all, we think of the major areas in my campus. We said the academic buildings over here and over there. So that's academic buildings. This is the students, and this is the faculty. Okay, so it's natural we think of those. In the world of software, those are like my main subsystems. Okay, I have a number of main subsystems here at a university. They work together, not so cohesive with each other, but they work together. Okay, for example, this could be my net classrooms. This is the registration system. Okay, this could be my Moodle and the education system. This could be some sort of an HRSS. Okay, human resources for the faculty and employment. Maybe you're not dealing with that at all. Okay, maybe another one would be the accounting system. Okay, you cannot have all of these systems completely disconnected from each other. Otherwise, you just have 4 systems. Okay, everything is somewhat connected. I mean, you pay to the accounting system. The accounting system kind of like pays the faculty's salary. Okay, but then the accounting system also tells Net Classroom, right, to go ahead and open up registration for you. When you open up the registration for you and you do register, then it tells the teaching system like Moodle, oh, that student have registered. So somehow, although we always think of these as completely different websites, okay, one is for Moodle, one is for Net, there is a little bit of level of communication, an interface saying, for example, Ranim, she's okay, she's good, she's paid, she's registered, please add her to the Moodle page. It'll take about 24 hours to add her to the Moodle page of the website. Now, the Moodle system and the Net Classroom system, they're not going to be living with each other, knowing every intricate details of each other. They just know some interfaces. Just give me the student ID and tell me that student is okay. That's more than enough. Okay. So what we're doing is I'm creating some sort of an interface between the different subsystems. And in order to think of this interface saying, well, Moodle is going to give Net Classroom this or Net Classroom is going to give Moodle that, I got to first of all even decide to begin with that Moodle and Net Classroom will have a connection with each other. Okay. So Moodle and accounting system, I can say to myself, I don't really need to have those connections. Okay, that's unnecessary. Why would Moodle be connected to the accounting system? Okay, so in other words, going back to the campus example, we think of the main areas, and then we start to think of the main road connection between the main areas. And we say, this is how you get from here to here and so and here to there, and this is the kind of information that you need. So going back again to the urban city example of Riyadh, okay, what we're thinking of, right, here is a major area, but also how to connect the major component of these major areas. Now, at some point later on, somebody's going to build a house over here, somebody's going to build a shop over here. That's not a big deal. That's not a concern at this point, okay? But at least I made it so that if you want to get to this area, this is the main highway that gets you there. If you want to go, say, from this area to the airport, this is the main highway you move from over there. So everybody of thinking, I was living in Al-Malqa like myself. If I need to go to the airport, we all sync on King Salman Road that takes us over there. Okay. If we want to go down south, we all sync on King Khalid Road that takes us all the way south. We all do the same thing. Everybody wakes up in Al-Malqa who wants to go down. They all take the same different minor roads, but to the same main road at the end. Okay. And then afterwards, yeah, go ahead, think of the smaller buildings, and then go ahead, in other words, the packages, the classes. And then after I think of the classes, I start to think of the different functions inside my classes, and then the different single lines of code, and so on. And at this point, I'm not really doing architecture anymore. I'm just doing low-level design at this point, okay? So that is, in a nutshell, what the first few slides are saying. And I prefer to actually do it like that instead of just flipping through the slides. All right, so this is what I'm, all of this is, okay. Now this slide is actually quite important. Now in this slide, there's two concepts you're gonna hear quite often during this course and the world of design in general. The word of cohesion and coupling, all right? Coupling is any interaction between a class in a subsystem and another class of another subsystem. Okay, means I've coupled two different subsystems together. Okay, cohesion means a connection between two different classes within the same package. Okay, if I take those two and I just spread them out between two, it's the same exact link. It just now have turned it from a cohesion thing to a coupling thing. All right, but in general, cohesion is what's inside a class, whereas coupling is what's between different packages, not inside a class or inside a package, and inter is between different packages. In general, what we want to do is we want to have within a package a high level of cohesion. Okay, now a high level of cohesion means go back again here. A high level of cohesion means, so this is my classes, okay, inside. I'd like to see them very highly connected as such, okay? That's cohesion, yeah. And now that I've seen those classes inside my package, I want to see them talking to each other quite a lot, working with each other, because in my point of view, that's really natural, okay? Now, think of something like net classrooms, okay? There's a whole bunch of classes over there that look at classes and courses and professors and students and making sure that there's no conflict and rooms and so on and so forth. You want those classes to be talking to each other, okay? Yet at the same time, when we look at something like Moodle, or even the accounting system, just to make it even more simple. Here, this is Moodle and accounting. Before I get into the connections between them, even the accounting themselves, the classes between them, I'd like to see a high level of cohesion between them. You know, they are talking to each other, okay? Yet at the same time, I'd like to see the least amount of coupling between them, okay? Really, the accounting system always should say to net classroom is that this student with that ID, they pay خلاص, that's it. No more لا توعقني كتير. Okay. There's no need for the classes of Moodle to go into accounting and know and talk to so many classes inside, and the classes of accounting to go into the class of Moodle and talk and say a lot of things together. They don't need all of this. Okay. They shouldn't. First of all, they shouldn't. And frankly, they don't want to. Okay. Let me tell you an example of why is it that you don't want to. Imagine you go into a restaurant. You want to sit down, look at the menu, say, I want this, and that's it. From your point of view, imagine if the server standing over there takes you inside the kitchen and shows you a lot of details about how this meal is actually being cooked up. And this is what, from your point of view, is like, thanks, but yeah, I want to eat. I got my friends sitting outside. I want to chat. You know, I don't want to be involved in all of this. Okay, here's a more practical example, which actually happens in the real world all the time. You go to a bank. You want to like take out a loan. You're creating a credit card. Okay. You end up knowing everybody in the bank. Okay. لا شباك 3 يقول شباك لا شباك 4 يقول شباك 6 مش عارف ايه ده بيشتغل يوم اللي مش عارف ايه. Why should I know all of this? I should just have an interface to this bank and say, this is my info, this is what I want. You know, and you should know the people inside. You talk to them. You shouldn't be, I shouldn't be walking around with my papers talking to every single class inside my bank. Okay. So frankly, I don't want to. I shouldn't, A, and I don't want. And when I say I shouldn't, that's because if I get to know the internals of the bank, this is where corruption might happen. I can start to play the system. Okay, so like this guy doesn't know that this guy is doing this, and this guy doesn't know that that guy is doing this. So I can then pretend that, and I tell him, oh, this guy said this, and this guy said that, and now I can work the system. Okay. Now here's another thing. You say cohesion, Doctor. You said something about cohesion. Why do you care so much that these classes are talking to each other all the time? Because if they're not within that package, if I take this guy over here, and I take that guy over here, and I move him over there, guess what? Those links that they have with them are gonna go. They're gonna be stretched across, right? Exactly. So those links are gonna exist whether we like them or not. Those links are gonna exist whether we like them or not. But since they're gonna be there, what I'd like to see them within the same package, right? I don't want to see them interconnected between different packages, okay? Which also helps me with the concept of reusability, okay? So somebody liked my accounting system and they want to use it in a different university. They look at it and say, okay, Stephanie, there's only one link that I have to watch out for. And then what is this one link for? Oh, just the student ID and an okay sign. Fine, I can handle that, okay? But if I put half of those classes that inside Moodle, inside over here, and I'm stretching along with it 50 different lines, all right? When you want to snip, cut the lines in the middle, there's so many lines to cut to the point you say, "What's the heck with it? I'll just create my own accounting system." Okay, that's just too much of a headache. All right. So let me go back again here. So architecture is not the operational software. We didn't really solve anything. We just laid the groundwork for success. Okay, it's kind of like putting a vision, right? Architecture at a high level, it allows us to check for correctness, efficiencies, and so on. So, you know, I just a moment ago I put the faculty in the wrong place. All sorts of problems I've got to figure it out before I even commit to that design. When I put the security gate smack in the middle of the campus, I can already tell this is going to be so many problematic. Okay, let me give you a different example that relates to the world of software about all of this. Okay, here it is. Oops, no, not this one. All right, so here is my client. You probably understand what a client server is, at least at a high level. Why is this keep snapping? Yeah, empty shape. I hate this. So here's my client. And here's the server. Okay, so on the client, I'm seeing a form. Okay, it has a whole bunch of things that you need to enter. Okay, naturally what you see that form and I see something like a submit button at the end. Okay, naturally it would make sense that I want to make sure that all the input is verified and it's corrected and it's complete while I'm still at the client, so that I don't have to send it to the server for the server to say, oh no, you've done this wrong, and come back again. Okay, and obviously I would want to, let's just send the whole form together in one shot. Okay, when I do that, I am doing what we call round trip. This is called a round trip. Round trips are very expensive. Okay, obviously computationally it's different than when you're looking at say an app or a desktop application where you kind of like do something as immediate because it's happening within your machine. Okay, it's just electricity talking to each other, just signals talking to each other. Once you hit something that requires a network connection, okay, you're going through different levels and then you get into the actual network, fiber wires, maybe going all the way to the United States and coming back again. It takes a few seconds or a few moments. And although right now things seem quick, it's still not as quick as if it was. Okay. So imagine this, just to give you the difference between them. Imagine if and this is why, pilots could never work from home, okay? I could have put everything, the software in a pilot, in an airplane, I can put it on a computer at the pilot's home, but it's going to be with satellite connection to connect to the airplane. But it's always going to be a little lagging, okay? And you don't want that. Now, in general, what I'm trying to say is, at some point, whatever is here, I'm going to send over here, but I want to reduce the number of round trips as much as I can, because it doesn't matter how fast we think they are, they're still not as fast as just being at the same point. Now, another reason why I want to save those round trips is because if each one of those items I go and back, coming back and forth and back and forth, that's 4 different hits on my server for the same form. Whereas if I send all of this in one shot, that's 1 hit. Multiply the client by 1 million, like say Facebook and Twitter and Snapchat and all that TikTok stuff, right? Then I've just multiplied the number of hits on my servers exponentially, okay? And this is why all sorts of technologies that we see in web-based programming, which is not much different than mobile-based programming, is all about getting the client to do everything while you're still at the client, so that you really, really minimize the number of round trips to the server and coming back again. Okay. All right. So things like Ajax and all sorts of fancy technologies and graphics technologies that existed, all of this is for the sake of conserving the number of round trips that we have. Okay. Had I had this setup to go back and forth and back and forth and back and forth and back and forth, as such, I know this is going to create me a lot of bottlenecks. So I haven't designed the application just yet, but I can tell already, before I even begin day one, this sort of architecture, not going to work with me. Now back again over here. All right, I have a little exercise for you. Let's build an architecture for a football league management system, okay? So we got like the Saudi Football League. I don't know how many Hilaliyah hina or Nasrawiyah or whatever, right? But you know, you're showing the fans, the schedule, the ticketing, and all that stuff, okay? Remember, we said we always start with a white page. So you got a white page in front of you, all right? You can go ahead, start creating something now. I'm just kidding. Exactly. You don't let me take it easy, take it easy. All right. All right. So I've given you all the flexibility in the world, but at the same time, I've given you all the responsibility in the world, right? Luckily, a lot of systems tend to have a lot of characteristics similar to each other. Okay. Yeah. I have a system, hotel management thing. I'm renting rooms. Okay. And I have another system, I'm renting cars. Big deal. Okay. Although this is talking about cars, this is talking about hotels. Technologically, it's the same exact concept, same structure. All right. Even if you think about it, what is that? How is that much different than, registering in a class? Kind of like if you rented the class from now until the end of the year, that's not much of a difference. Okay. And what I'm trying to say is, a lot of systems at a very, very high level, you remove all the specific details and the characteristics and the flavors. Ultimately, they're exactly the same. And that's why you see companies like Booking.com or Expedia, they start off with hotels and they say, well, I might as well just do flights because they're exactly the same. And then, well, I might as well just do cars as well. Oh, look, I'm gonna do vacation packages, because from a software perspective, they're all exactly the same. Okay, they're all exactly the same. So what we have is something called architectural patterns. Okay, architectural patterns are common solutions to common problems. Okay, so think of the whole house and door thing that I said before, huh? And realize, okay, well, this type of a concept of a general concept of a door would work on a general concept of a house. I can actually look at many different problems, and every problem will be different, but I can still generalize them into a general concept. So trying to get from point A to B, then I get the cars from here to here. Pretty much that problem is going to be different in Riyadh than say in Sydney, than in New York, and so on. But the specifics are going to be different. But it's still the same problem. I'm trying to get them over here, over a river. Okay. You look at the specific solutions. Okay? The bridge that we have over here is going to be obviously not exactly the same, a carbon copy from the one that's in New York than the one that's going to be in Sydney. But in general, the general concept of a bridge is exactly the same. Okay. So problem n+1, another point A to B situation, I have to do two things. First of all, I got to have the common sense to recognize that this is a similar problem to what I've seen before, so that I can resort to the common solution that has happened in Riyadh, that has happened in New York, that has happened in Sydney, i.e. building a bridge. And then this is how you go ahead, and we teach students in civil engineering how to build bridges, the general concept of how to build bridges. Okay. So in the world of software, we have the same thing. We started off with a white page, but we got some help. It's a very daunting task. Had I just asked you, say, here's the white page, start drawing, you really would say, I don't know where to begin. Okay. Luckily, we'll have a lot of points to know where to begin. But actually, before we actually begin with the solution, note, yeah, that's actually a harder part. And a little later in the course, we're going to take something called design patterns. Design patterns is the same thing as architecture, but at the lower level, the lower box. Okay. And the hardest part for a student and answering those type of questions is to what I'm going to do. I'm going to give you the specific problem. Okay. Why? Because the world is not going to tell you, oh, this is a general problem. This is just going to give you the specific problem. Well, we're trying to get from here to here. Okay. It's the ability to see the pattern and say, oh, well, this problem, it's basically just like this problem, that problem, this problem, that problem, which uses that general solution. Okay. And in the next lecture, we're going to be talking about the different software architecture. We have data flow, client-server architecture, very common. Everything that you have on your phone is all client-server architecture. Repositories, virtual machine, also very, very common. Layered architecture, extremely, extremely common. Okay, and even more common is something called the MVC, and it's not just one architecture per system. A lot of systems would actually deploy multiple architectures at the same time. Okay, two of the most common ones, like I said, is client-server architecture. It's very, very common. Everything you do, so you booked something on your phone, you open up your laptop, it's there. Okay, you've registered in a class, you open up your laptop, it's there. Okay, because of the client-server architecture. Okay, then we got the MVC, model view controller. All right, let's just say you opened up two windows in your laptop file explorer, same folder. Okay, you click on one to delete a file, it's gone on the other one. You don't have to go back and delete it over there too. Okay, that's MVC. That's what made something like Windows even become a thing before probably all of you were born. And that's what it made it shoot to popularity as such. Okay, so I do it in one place, it sounds in everywhere else again. All right, we'll talk about this in the next lecture. So that's going to be it for today. I'll see you on Monday. I've shared with you a playlist link on YouTube so that it's the same link every time you reach, you get to see the next video. Okay, guys at home, any last questions? All right, thank you, Khalid. So I'm gonna be now ending this session. Have a good day, everyone.
I thank you.